I'm Jeff Zarnett, and this is a bonus episode of Software Career Growth called Secrets of a Hiring Manager. This talk started its life as a data structures and algorithms interviewing conversation. I was invited by the Engineering Society of the University of Waterloo to prepare a talk on data structures and algorithms for students who are interested in passing, data structures and algorithms interviews. I maybe went a little off track with what they wanted here because, I'm not going to teach any specific data structures or algorithms, right? Why not? Well, the real answer is I want to zoom out a little bit and I want us to focus on sort of the process, right? Like what's important here is just as much like how you approach the interview as anything else. And the specific data structures and algorithms, they can come later. So my real title for this talk is Secrets of Hiring Managers. And to get it off the top here, right? I've hired a lot of people during my career, and there's a number of things that I think are kind of important to call out pretty early on. The first one is that I want to hire the right person, but I really, really do not want to hire the wrong person. Hiring the right person is difficult. It often takes a lot of interviews, and certainly these days interviews have a lot of rounds and a lot of questions and can feel quite intense from the candidate point of view. Right, but one of the things that I really do not want as a hiring manager is to hire the wrong person, because that's painful, right? It's painful and it's expensive. It sucks to hire the wrong person because they don't work out and you have to hire again in a few months, but also in the meantime they may have done a ton of damage to team morale or caused production issues or bugs or what have you, and that's not a good outcome. So of course I don't want that. But the interview process is testing for basic skills when we're talking about some sort of data structures and algorithms thing. Like I want to know, can you solve the problem that's being put in front of you, which is a test of your knowledge of computer programming. But more than anything, I'm looking for communication. It's not just whether or not you came up with the right answer or the optimal code or whatever it is, but also how do we communicate? Did you answer questions directly? Did you seem like you understood how to interpret instructions? All those things come up in terms of communications. The other thing that I will say about data structures and algorithms problems is many of them are cargo cult. There's a certain amount of everyone else in the industry is doing this, so we do that too, even if that's not actually meeting our objectives, right? The things that we are looking for in the interview are not necessarily the things that are needed to be successful in the role, but we'll come to that in a bit. One thing I would really like to make clear as we get into this process is that hiring is very imprecise. As much as we try to put rigor into it, and as much as we try to do our best to make it as good of an outcome as possible, hiring is challenging. Right? Even 90 minutes is not enough time to truly understand a candidate's skills. If we have a 90-minute interview, 10 minutes goes to introduction, icebreakers, that sort of thing, right? Then we get to spend some amount of time talking about 60, 70 minutes, and the last 10 or 15 minutes is candidates' questions for the interviewers, right? And so in total we got 60 or 70 minutes of talking about candidate skills. That's not enough time really to truly understand whether someone is good at this or has lots of relevant experience and what have you. You get a small glimpse of it. Whether that glimpse is sufficient is hard to say. Right? Another thing is that potential is very hard to evaluate in interviews. If someone is able to solve the problem, that's presented in front of them, of course, that looks good. That's a thumbs up. But if this is the sort of thing where someone might not have been able to solve this, but if they went off and spent an hour learning, then they would be able to solve it. You can't see that in the interview. right? That person clearly has potential. They would be successful in solving the problem, but it's hard to see that. And of course, it's hard to know, especially if you're hiring like a junior person, like, is this someone who's going to go on to be a staff engineer or principal engineer or something like that? Like, it's very challenging to identify that when you only spend an hour with them. Third point is that luck and external factors can tilt decisions, which is just to say that you might do the interview very well, things might go swimmingly, you might be able to answer all the questions in a very efficient manner, but then the boss wants to hire his best friend's nephew or whatever, literal nepotism. And if that's the case, right, that sort of tilts the decision. You can also end up with the situations of just the luck of who your interviewers are, that you might have been able to pass with 9 out of 10 combinations of who the interviewers are. You don't know. Right? And the last is that humans have biases and are fallible. As much as any company might invest effort in trying to make the interview process rigorous and reproducible and fair and eliminate bias and what have you, there is no way that you can get a totally unbiased evaluation. Humans just are fallible. They sometimes make the wrong decision, and there's no getting around it, right? We can make lots of efforts to reduce biases, and part of the reason for having, say, multiple interviewers is to try to smooth out the fact that humans are fallible, and we can collectively do better than any one individual, but there's no perfect solution here. And if you are thinking, if you're writing in the comments right now, oh, the solution is AI, we'll just train the AI. No, that won't solve it. Part of the problem with that is what do you train the AI with, right? And how do you ensure that you're not training the AI to be biased? There's been lots of news stories about companies that try to use AI or machine learning or something like that for hiring, and it ends up hiring only people who are very, very similar to the people who are currently at the company, even though that isn't actually what's making them successful, right? Like, skills and experience are relevant, not their demographic information. Anyway, so as an interviewer, there are some things that I want to see. Right? These are the things that I'm looking for. These are the positive attributes that I am hoping that the candidate is demonstrating in the interview. The first is problem solving. Like, yes, if we are doing a data structures and algorithm interview, right, there is a problem to be solved, and I would like to see that problem be solved. That's part of it, for sure. But I'm also interested in communication. So how do we talk about this? If I ask a question, can you give a direct answer? Does your answer have sufficient detail, not too much and not too little? Are you able to sort of talk through your thought process while you're working on this problem? Tell me what it is that you have in mind, and that sort of thing. And I'm also interested in openness to feedback. I've said on a number of occasions that software development is a team sport, or at the very least a team activity, right? And it is super common that you're going to put up your code and get code review. And if you have high openness to feedback, that's good, right? The goal is to make the code the best it can be, and being willing to hear some feedback and use that is an important part of the work to be done. But things that I don't want to see, silence. I mean, you could consider this in some sense the opposite of communication. If you are thinking about it, tell me that you're thinking about it. If you're stuck, it's okay. Just say you're stuck. You're working on it. Something like that. It gets very awkward if there's a lot of silence, that's for sure. I also don't want to see defensiveness. This is kind of the counterpoint to what I just said about openness to feedback, that if someone has a suggestion or a hint, I want to know that you're going to take it well and you'll apply it, and that hint may be useful, it may not be. If someone gives some feedback and you have an argument that says, actually, I think it's better this way because, right? Like, that's not defensiveness. But it does become defensive if you are totally not open to feedback. And the third thing that I really don't want to see is memorized answers, right? There are a number of different problems that you could be presented with, the data structures and algorithms kind of scenario, and you can read advice on the internet that says, well, if you simply memorize all 200 of them, then of course when you get in the interview, you'll know exactly what to do. If I get the sense that you've memorized your answers or you've written them down, or some some tool is helping you with them, that's not a good sign, because it's not accurately reflecting your problem solving capability. Okay, so what's your high level plan? You're presented with a problem and you are now going to go about solving it. So the first thing that I'm going to say is listen carefully, right? You're going to be presented with some amount of information that is necessary to solve the problem, okay? So listening to that carefully, write down some notes if you need, is good. It gives you a better place to start with than just jumping right in before you've heard everything that's been said. The second one is ask for clarifications if you need it. When the problem is being explained to you, there are certainly possibilities of something being ambiguous, or some scenarios that you may or may not have to consider, and asking about that up front is good. It helps you refine the solution when it's the easiest to do that. The third thing is you decide on your approach, and we'll talk more about the approach as the next thing. But once you've heard and understood the problem and asked your clarifying questions, then you can sort of plan out what does a solution look like, and you should explain out loud before and during your work. So you've heard the thing, you've asked your clarifying questions, you formulated a plan. You say, okay, my plan is this. And as you go about executing the plan, then sort of say what you want to say. And so about the plan. Great. So explain what you want to do first. I just covered. And the next thing that I would suggest is start with brute force, or at least the simplest solution that you would know works. Right? This kind of makes sense, but it might actually seem counterintuitive, right? Like, doing the brute force algorithm or whatever, might not get you everywhere that you want to go, but it is much better to start from something that works and is not optimal and then refine it to make it better than it is to try to go directly to the optimal solution and fail. Right? If you don't have anything working because you tried to go to, there's the n log n solution or whatever, but you weren't able to pull it off, that looks worse than we started with the n squared algorithm and then we tried to improve it, and then it got better. Right? Whether you actually succeed in the improvement, at the very least, at the end of the first stage where you have like the brute force algorithm, you do have it working, so that's good. Then, once you have something that works, you can think about how to optimize it, right? There are a number of different strategies for optimization that we will talk about in a minute, but that's kind of the next step is, okay, given what we have, can we refine this in some way? And then finally, test what you wrote, and if there are any bugs, fix them. Okay, right? Testing is interesting. We'll talk about that in a minute as well. So we'll zoom in ever so slightly. So if you're writing code, right, sometimes pseudocode is all they need, and particularly if this is like an in-person interview where like you're getting a whiteboard or something, you don't type with the keyboard and you don't get the benefit of like a compiler or an IDE or anything like that. And if that's all they need, then pseudocode is probably okay. Certainly it's a little bit easier to write pseudocode than it is to get into the details of some things. If you do get to choose a language, pick one that you know well. So you might be interviewing for a position where it's like, well, this company uses, I don't know, Ruby or something, but you don't know Ruby. And if you get to choose, you would choose JavaScript because it's a language that you know really well. It is much easier to say, I'm going to use a language I know well and be sure that you solve the problem than it is to struggle with the syntax of a language you don't really know because you think that language would be more impressive to the interviewer, right? So pick one that you know well. If you're going to do a remote interview that uses some sort of online platform, in many cases in the lead up to the interview, you can ask what the platform is going to be, and then you can create a free account or something like that and like practice a little bit with that platform. Why would you do this? Well, the thing is that every platform is a little bit different, so how you enter the code and what keyboard shortcuts work and what it takes to compile the code and everything, like all of that is different from platform to platform, and if you're at least a little bit familiar with it before you try to do the interview, then there's just one less thing to worry about, and it is way less stressful because you're like, okay, I know how to compile this, I know how to view the output and everything, instead of trying to figure that out alongside trying to solve the problem. And then, of course, this last point I've already gone over, which is it is better to build from a non-optimal solution than to fail at going straight to one that's optimal. Okay, so what do I mean about optimizing? Well, let's zoom in on that a bit too. So one of the things that I would suggest is make sure that you're using all of the information provided. If somebody mentioned something to you in the problem description, it is extremely likely that it has a use at some point in solving the problem. Whether you need it to like solve the problem at all or whether you need it to optimize, it's probably there for a reason. This is one way in which the interview process is a little bit different from real life. In real life, there's lots of extraneous detail, and you have to figure out which things matter, and that's fine, right? But in an interview, chances are you have the information for a reason. Okay. And then 3 points that, if you've not read the book Cracking the Coding Interview, I medium recommend this book. It is bottlenecks, unnecessary work, and duplicated work. So you want to eliminate those things as much as you can. And bottlenecks are things where, okay, this is what holds up the execution. It's the slow step. It's the part where everybody's waiting for the same thing. That sort of thing is a bottleneck that needs to be solved. And unnecessary and duplicated work are pretty self-explanatory, right? Like if we've already found the thing that we're looking for, we can just return from the search now. We don't need to continue to search because, again, we already found it. And duplicated work is the kind of thing where, like, we seem to have sorted this multiple times, before we search it. Like, well, what if we could just do that once? Right. And here, when we're talking about optimization, the kind of optimization that we want to do is the algorithmic complexity kind of stuff, right? We would like to improve the way in which the program executes as based on the number of input elements. Okay, let's imagine though you get stuck. This can happen. That's okay, right? Is it hard for you to ask for some help? I am totally this kind of person. I am the kind of person who would do the two-person furniture assembly all by himself because it somehow feels easier for me to just suffer than to ask somebody to come over and give me a hand with it. It's fine. Right. Getting stuck can happen, and it's not the end of the world. Now, as an interviewer, right, do I mind if somebody needs a hint? Not really. If they need a lot of hints, that's maybe more of a problem. And certainly, for someone who's junior or intermediate, needing a hint is viewed more positively than someone who's telling me they're a principal engineer. But can you ask for a hint? Yes. Right? The interviewer would like you to succeed, and it is a way to show a certain level of maturity. If you say like, I'm not sure what to do here, right? That is a way of communicating and a way of showing maturity and the kind of thing that I would want to see in the workplace, right? If you're stuck, you should, normal workday kind of situation, try to do stuff to get yourself unstuck. But if that's dragging on for too long, the rational choice might be ask someone who's more senior or more experienced or knows the code base better or something like that to get yourself unstuck, because sometimes that 10-minute conversation could save you 4 hours of trying to solve the problem yourself. That's a good investment of time. So being willing to ask for help is not a bad thing. That leads us into testing. And for testing, I'm going to say start with evaluating the happy path. And the happy path is, this is the normal scenario. This is, everything is going fine. Nothing is wrong. Normal workflow. Okay. Then you can think about special cases. Like what happens if the array is empty? What if the array is of size 1? What if the array is already sorted? Something like that. Once you've handled sort of many of those scenarios, right, you've probably covered a lot of the potential edge cases or corner cases, but you can always sort of look at your code and think about, are there any scenarios that stand out to you, right? Like, if you look at the function, it says, if x is less than 7, it's like, okay, there's probably something interesting there that happens if x is 7 or if x is 6 or if x is 8, right? Like there's hints of what you can look for in the code, right? And you should look for common faults as well. Things like an off by one error. We started at 1, we should have started at 0, or we need an extra iteration of this loop for something. And also forgetting to free memory, assuming you're working in a language where that's a thing that needs doing. Right? Did we initialize everything correctly? Did we destroy everything correctly? Is at least worth looking into. Okay, then the interviewer may, and this could happen at any time during the process, give you some feedback. And the feedback might be new information that changes things. They say, actually, so it turns out we do care about this scenario, or what if you had 10 times as many this? Those sorts of things can happen, right? This is helping you to adapt your solution in some way. Now, it might be that, okay, I'm trying to assess how well you take feedback. Okay, I've changed the conditions now, so are you able to adapt to that? Hopefully, yes. If not, that presents a problem. They might be trying to help you get unstuck if it seems like you're not making any progress, or you're going down the wrong path. The hint that you might be getting, or the new information that you might be getting from the interviewer, is intended to help get you back on the right path. And again, listening to that will be helpful, and I want you to take the hint and use it. And the third reason is there might be more optimal approach than the one that you chose. If I am hinting at something, or pushing you in a particular direction, it is maybe because I see you're going down a certain path, and that perhaps with a little bit more information you would land on the optimal solution, something like that. In all of these scenarios, I would say that I would hire a coachable person over someone who knows the answer but can't take feedback. Lots of people know the answers to things, they've memorized it, or they've looked it up, or they worked it out, or whatever, but being coachable is extremely important. This goes back to what I was saying about it being kind of a team sport, that someone who is coachable, is open to learning, open to improving, will be better to work with than someone who's an insufferable know-it-all. So don't be that person. I would much prefer you be someone who's open to feedback. Okay, then when the interview is over, I'm going to be asked to fill in a scorecard in whatever applicant tracking system we're going to use, right? And the things that I'm looking for are basically all the things that we've just talked about. The actual questions will be different, and how it's organized in the applicant tracking system doesn't necessarily look like this, but these are the things that are primarily relevant, which is number 1, did you solve the problem? Right? If you didn't solve the problem, that's a bad sign, but depending on the level and the nature of the problem, it might not be the end of the world, depending on how the other attributes here went. Was your solution correct? Was it efficient? Was it readable? All of those things are good, and again, you don't always have to get perfect efficiency on this sort of thing, but it is a thing that I'm looking for. And did we communicate well? Again, very important, because we're also trying to work out not just, do you have the raw skills in terms of data structure and algorithms or problem solving, but I also want to know, are we going to be able to work together? Are you going to be a team member in my team who is a contributor and who is somebody who is pleasant to work with and improves the team, as opposed to being, like we were talking about before, someone who's insufferable and hard to work with. And then the last one is, are you open to feedback and learning? Again, you'll get better at what you do by being open to learning, and being willing to grow is very beneficial. If you're giving me indications that that's not the case, then I don't know how we're going to work together in the future. Now, it is important to remember that what I said earlier about interviews being imprecise is true, right? Interviewers sometimes do things that can charitably be described as not best practices, right? They give you an impossible problem, and there's no way to solve it, and they're frustrated with you because you didn't solve the impossible problem, right? There's no good reason to do this, but people do. Another thing that is potentially a problem is expecting you to read their mind. Right? Oftentimes, a sufficiently interesting problem has more than one valid solution, but they're expecting that you will do it exactly the way that they would do it, or exactly the way that the solution in the solutions manual says. That's not great, and they're expecting you to read their mind, and there's kind of no way to do that realistically. Right. The third thing is, making it an interrogation, not a conversation. If you feel like they're just throwing questions at you and bombarding you with all of it and everything, like it's not actually an open dialogue and not a good indication of like how are we going to work together. And I would not recommend that as a practice. Okay, so let's say that you do actually want to do some data structures and algorithms problems. So I've got some do's and don'ts here. Number one is grind lead code, but in all capital letters, in moderation. Some amount of lead code is good, but making it your full-time job, and I spend 5 billion hours a week grinding lead code, if it doesn't help. Right, like being familiar with some of the things that need doing, sure. Learning a bit about important data structures and important algorithms, and practicing those is good. But you very quickly run into diminishing returns with this leak code stuff. You can accomplish what you need with a reasonable investment here. Right, you should be familiar with common algorithms. Know a little bit about trees and graphs and stuff like that. Like this is important to try to understand many of the things that you're going to come up against. You want to have some amount of tools in your toolkit, if you will, but again, in moderation. Right, common algorithms, not every possible algorithm. And then simulate real conditions. So if you want to do one of these, leak code or other exercises, like you can, but treat it like it's an interview. Don't just look at the problem and then say, okay, well, I'm going to do this with Google and ChatGPT and what have you. If you're not going to have access to those things while you're doing the interview, you should try to make it seem as much like real life conditions as possible, so no distractions, focus on the thing that you're doing. It's very much the same with like if you were doing a practice test in university. You want to simulate the test conditions to be like the exam conditions will be, to try to understand what to do and how to do it. And what I said earlier about if you get to use the platform a little bit in advance, that's also worth doing. Become familiar with it because it will help to have had that figured out. Right. In the don't column, don't try to memorize solutions. This is what I was saying earlier on about like if it seems like you've memorized all of the answers, I'm not impressed. I would like someone in the team who is capable of solving problems and taking on new information. So if you've seen this problem before and you know the answer and you can recite it with a snap of your fingers, right? You're not convincing me that you've actually got the problem-solving skills, because real life often presents us with problems that we haven't seen before, and that's more interesting than here's a memorized solution to this graph problem. Similarly, don't try to memorize every algorithm. There are too many of them, and there's no way you could possibly memorize every single one. And even if you did, someone could invent something new that you haven't memorized. And if you're presented with that in an interview, like, what do you do? Again, the goal is to be able to adapt to new situations and not just memorize every possible answer. Right? The last thing is, don't assume that reading is enough. One of the things that you can get wrong, and this applies to study strategies as well, is the idea of like, well, I looked at the problem and I look at the solution and I say, okay, yeah, I knew that, or I could have done that, or I understand that. You will only get good at this sort of problem solving by actively solving the problem, so just reading is not sufficient. To close out, I want to remind you of something that Captain Picard says to Commander Data in Star Trek The Next Generation, which is, it is possible to commit no mistakes and still lose. That is not a weakness, that is life. You can do all of the things that we've talked about in this topic. You can solve the problem perfectly during the interview. You can communicate it well. Your solution can be optimal. You can get there in zero time at all of that, and still not get the offer, because any number of reasons, right? There was another candidate who was like better. There's an internal candidate who was going to get promoted. That entire division has just been eliminated at the company and has been and has been laid off. Like, all of those things can happen, and those things are not your fault, right? It is important to remember that the interview process, in addition to being imprecise, is sometimes unfair, and that you can interview very well and still not get an offer for any number of reasons. So please don't lose hope if that happens to you. There are lots of things that can go wrong. All you can do is do your best in the interview, and hopefully this topic has been beneficial in helping you do that. All right, that's all on this topic. Thanks. Best of luck with your interviews.